an angle of 45 degree to this cutting plane line like this. These were lines makes an angle of 45 degree with this cutting plane line, which is at an angle of 45 degree like this. So this represents the true shape of the section. So you can write here it's a true shape, and this is the front view. Now next step is to draw the side view of this cylinder. So for that we have drawn this side view. Now in this side view, identify the position of this cut portion. So for that, let me name the generators over here. Here generator 1 is there at the middle, so here is generator 1, 2 is over here, so here is generator 2, 3, 4, 5, 6, 7 and 8. These are the imaginary generators drawn to the outside periphery of this cylinder like this. From here like this, from here it's like this. Now find out the position of each point on the periphery. Say point number P1 is here, P1 is on generator 1. So from that one P1, draw horizontal line up to 1. So 1 is here, over here. So this is point number P1. We can write here the name, it's a P1 point. Similarly, point number P2 is over here on generator 2. So from 2, draw horizontal line up to generator 2. So it is somewhere here. This is point number P2. 3 is here. So of course P3 would be here. You can write here P3. 4 is not there. Then again back to P3. P3 is here. So here P7 is here. So from here P7 point would be here, and P2 here is P8. 7 is here 8. So from P8 draw horizontal line that will cut generator from point 8 at this point. So this is point number P8. Now again join all these points with a smooth curve, as it's a cylindrical portion. So it would appear like this, right? So this shows the sectional side view of this cylinder. If you cut this cylinder at an angle of 45 degree, and if you look from the side, it would appear as shown over here. Here also line would be visible, which shows this upper edge. So this cylinder is also cut over here. So here also same procedure should be repeated. Take projections from the cutting plane and imaginary generators. Here the cutting plane is this one. Let me mark it with the red color line. This is the cutting plane, an intersection of this cutting plane and various points, various generators. P1 is here, say here P2 dash, here P3 dash, P7 dash and P8 dash would be there. And from all these points draw horizontal lines and respective vertical lines. So here the points of intersection would be here. Just it's a repetition of the upper step. Find out the position of the points and join them with the smooth curve. So that would be also the mirror image of the upper parabolic shape like this. And here also outside lines would be there, and this bottom line also would be there, because the edges would be visible. If we cut the cylinder, then also its edges would be visible to us. And this is the name the view, it's a sectional side view of this cylinder. So this is the complete problem. I hope the solution of this problem is clear to you. Now example number 3. And the data is given like this. A right circular cone, base 50 mm and axis 90 mm long, is lying on HP on its base. A sectional plane inclined at 30 degree with HP and perpendicular to VP is bisecting its axis. Draw its a sectional side view, sectional plane and true shape of the section. So here brief data is like this: a cone, diameter 50 mm, height 90 mm, base is on horizontal plane, section plane 30 degree to HP and perpendicular to VP, and it bisects the axis. So here first cone is given, so draw an XY line which represents intersection of HP and VP. This is the given condition. Cone is given and this is the cut portion, 50 mm diameter, 90 mm height, and this is a cutting plane which bisects the axis. So this midpoint of this axis is somewhere here, and from that midpoint draw a line which makes an angle of 30 degree with HP, and this is the cut portion which would be elliptical in shape. This is represented by this pink colored, this is an ellipse. Now draw XY line that represents intersection of both the planes HP and VP. Draw a circle below XY line of diameter 50 mm. Insert the dimension like this, 550. Don't insert the radius in the dimension. Draw its axis, vertical axis and horizontal axis, and from the endpoints draw projection lines like this, and height is given, that is 90 mm. So at a distance of 90 mm from this XY line, mark a point over the axis. So this 1, 2 and 3 points are there. Join these 3 points, which represents the front view of this cone. If you look from the front, it would appear as a triangle as represented over here. Now further, it is given that the axis is bisected by a cutting plane. So find out the midpoint of this axis. So total height is 90 mm. So at a distance of 45 mm from the base on the axis, mark a point over here. From this point draw a line which makes an angle of 30 degree with XY line like this. So this is a cutting plane line which passes through a midpoint of this axis over here, as well as it makes an angle of 30 degree with XY line. This angle is 30 degree. Now this is a cutting plane. How to find out the true shape and other points? So for that, let me divide this circle, this one, into equal number of parts. This top view into 8 equal parts, 1, 2, 3, 4, 5, 6, 7 and 8. So 8 equal division is there. From each points 1, 2, 3, draw imaginary generators from 2 and 8, one vertical line over it. It will cut the base over here. Join this point to the apex point O, vertical line from 3 and 7, vertical line from point 4 and 6, and these are the imaginary generators as we have drawn. Now after drawing these imaginary generators from this top view, let me find out the points of intersection between this cutting plane and this generator. See, this is a cutting plane and these are the generators. So first point is here, the intersection of this cutting plane and the generator O1. O1 generator is here. So from this point draw straight vertical line like this, intersection of this cutting plane and O1, like from here it will cut O1 in top view at this point. Here O1 is top view of O1 is here, and here is the point, that is point P1. Similarly, intersection of O2 or O'2' and cutting plane is this point. So from this point draw straight vertical line that will cut O2 at this point. So this is point number P2. Now P4, here intersection of this O4 and cutting plane is P4. So from this point draw straight vertical line like this. This straight vertical line will cut O4 at this point. So this is point number P4. And P5, intersection of this O5 and this cutting plane P5 is here. So from this point draw straight vertical line that will cut O5 at this point. So we have identified 5 points, and similarly on back side also the same points would be there. Vertical line from here on O6, here is the point, on O8 here is the point. Now what's about generator O7 and O3? So for that, let me transfer the intersection of O7 and cutting plane is this point to over here. So transfer this point on the true length of the generator. That is O1 is the true length or O dash 1 dash is the true length. So transfer this point to the true length. From that it will cut, from that draw straight vertical line that will cut O1, that is top view, at this point, and take O1 as a radius, draw an arc. One arc is on this side, another arc is on this side, and that will cut O7 and O3 at 2 points. So these are the position of these points in top view. Now join all these points with the smooth curve like this. So this is the cutting portion. If we cut this cone at this angle, this would be this would appear, and this is called as sectional top view of this cone. Now next, this is the front view of this cone. Now we have to draw the true shape of the section. So for that, what should we do? The steps are similar to the previous problem. Here find out the position of all the points. P1 is here. So from P1 draw a line which at a right angle to this cutting plane. So this angle is 90 degree. P1, similarly P2, from here, from P3, P4, from all these points draw lines like this and measure the distance of respective points from XY line to top view. Say P1 is here, so measure the distance between P1 and XY line, mark it over here. For P2, XY line to P2, mark it over here. For P3, mark that distance over here. So P3 would be here, P4 point would be here, then P5 would be at this point, P6 would be here, P7 is here, then P8 is here, and join all these points with the smooth curve like this. This smooth curve represents the true shape of the section. You can write the name, it's a true shape, and you can draw the section lines in this shape also. Now how to draw the side view of this figure? So for that, draw here line at an angle of 45 degree with the XY line to the left side of this top view, and take projections from this top view. Horizontal line from 7, horizontal line from all the points, and vertical line from point here from 3 like this, and horizontal line from apex point O dash, and projection line from this apex point over here, and join these 3 points, and this triangle represents the side view of this cone. Now how to draw this cut portion in this side view? So for that, draw each generators, horizontal line from 8 and 6, horizontal line from point 2 and 4, and means transfer all these generators in side view as well. That is O1, here would be O1, here would be 2, 3 would be here, 4 is here, 5 would be here, 6 is here, 7 is here, and 8 is here. Now each generator position is known to us. Transfer all these points P1, P2, P3 up to P8 from this front view to this side view. So for that, what should we do? For that, from P1 draw straight horizontal line that will cut O1 at this point. From P2, 2 is here, draw straight horizontal line that will cut O2 at this point. From P3, straight horizontal line, it will cut O3 at this point. P4 is here, so it will cut O4 at this point. P5, it will cut O5 at this point. P6, it will cut O6 at this point. P7, it will cut O6 at this point, and P8. So this is the 8th point. 8 points are there. Join all these 8 points with the smooth curve, freehand smooth curve, and this is the sectional side view of the figure of this problem. And here in examination you do not have to use the colors, you can use just the pencil. So draw here section lines as represented over here. This is the pictorial representation and this is the actual drawing. In exam you do not have to draw like this. In exam you have to represent your work like this. If you draw the problem these 3 views and true shape, you will get full marks. I hope the solution is clear to you. Now next problem, Question number 4. A pentagonal pyramid is standing on its base on HP, whose one side is perpendicular to vertical plane. It is cut by a section plane 45 degree inclined to HP and perpendicular to vertical plane through midpoint of the axis. Draw front view, sectional top view, true shape of the section if side length is 30 mm and height is 50 mm. Here pentagonal pyramid is given and you can write the small data like this. It's a pentagonal pyramid 60 by 100 on HP on its base. One side is perpendicular to vertical plane. So first of all, draw XY line and draw one side which is perpendicular to XY line. This length is 30 mm if dimension is 30. Here then draw a pentagon. Sorry, here 60 is not there, or here 60 should be there. Instead of 30 you should write 60. Then draw a pentagon in such a way that this line becomes the base. Then name the endpoints A, B, C, D and E. 5 endpoints are there and it's a pyramid, so it will have an apex point. So for that, join to find out the midpoint of this pyramid, join the corner with the midpoint of opposite side. So midpoint of BC is here, join to E. Similarly, join midpoint of AB and D, and both these line will intersect at this point. So this is the axis of this solid. So from this point draw the axis of this solid, and height is given, that is 50 mm. So at a height of 50 mm on this axis from XY line, mark a point. Now take projection from AB and D. From AB here is the projection and from D here is the projection, and join these endpoints, and this triangle represents the front view of this pentagonal pyramid. Now locate the position of E and C. So for that, draw vertical line from E and C up to base and join that point E dash and C dash to this apex point. And as OC will be visible to us, OE will not be visible, hence we represent this full line. Now it is given that we have